Hey, what's going on, folks? It's Mike here, and welcome back to the D Programming Language series. In today's lesson, we're going to take a look at something known as Typedef. We've been talking about in previous videos things like is and templates, and this is going to be a really useful tool for constructing new types. But types that might be identical in some way, such as, well, they're representing floating point values, like, for instance, currency, where you have dollars and euros, for instance, but they're not exactly equivalent. So we want to make some sort of template for them so that when we compare them, maybe we get some sort of error, for instance, if we accidentally mix units. So this is one tool that's built into the standard library that could help you, or at least help you get started with solving this problem. Let's go ahead and take a look. So I'm going to go ahead and take us to the documentation page and then library reference. And if we search, I'm going to look for Typecons here, short for type constructor. If I go ahead and scroll down, though, you'll notice it's under two categories, one for the memory management, but we're interested more so in the metaprogramming, type section here. Okay, so I'm going to go ahead and look at Typedef here. So as I prepare this example, let me go ahead and just minimize this window a little bit, and we're going to look at Typedef here. Okay, so I'll go ahead and have this set up here so we can go ahead and follow along with the examples. But the basic idea, and I think the easiest place to start, is with that money example. So we can see that we have an example down here. And basically what I want to think about is something like currencies, which again would be represented with maybe floating or double precision values. And you have money in euro and money in dollars. But you do want to assert or be able to compare that these aren't the same things. So again, if you have some sort of application, let's say you're building an application where you need to process payments, but you don't accept some sort of currency. Now, the underlying thing that's probably stored in the database is still a float, but at the end of the day, too, maybe you're able to only handle euros or only handle dollars, or otherwise just want to use this as a routine to make sure that you can get the correct conversion. Okay, so that's the basic idea. We'll come back and code this example, but I hope that makes it clear what the motivation is. You can see that the underlying types are the same here, and we can basically create our own alias. Okay, so let's go ahead and scroll up here and start with just a basic example. So again, Typedef allows the creation of a unique type, which is based on an existing type. And unlike alias, Typedef ensures the two types are not considered as equal. Okay? So again, it's a little bit of a stronger alias, meaning that it is actually type checked and will report that two typedefs are not equivalent, or at least make it harder to do so. Okay? So let's go ahead and take a look here. Now we still have this alias feature to make things useful, right? Just so we don't have to type out Typedef with a pound sign and int. So let's go ahead and play around with this just a little bit here. Let's go ahead and code up this example here. So I'm going to create an alias. I'm going to follow along with the myInt here. Create the Typedef for the int type here. Again, it just takes this particular example. I'm just using one parameter, but we can surround that in parentheses. And that's all we need here. Now let's go ahead and just import the Typecons library to make sure that we have everything ready to go here. And you'll see that I can use my int with the same operations that I previously had for an integer. Again, because it's sort of like an alias, but again, not quite. Okay, so it's actually, again, giving you the capabilities of the underlying type here, for instance. But otherwise, it is considered as its own type here. Okay, because its type is this Typedef here. Okay. So let's go ahead and just do something with my int. So let's create some value. Again, I'll set it equal to 10 here, and we'll just follow along with the example here and write out the value. And let's go ahead and compile this just so that we can see if I type it out properly. Capital I, there we go, my int for the type. Again, I like to use capitals for my types, so there we go. And we can see that it's working here, okay? So again, just to push this a little bit further here, let's go ahead and just create our own struct. Let's just call it S for now, for lack of a better name. And let's add some helper function here. I'm just going to say call me, just some function here. Write a line here, called me, okay? And let's go ahead and use this custom type now with Typedef, just so that we can see how this works. Okay, so just doing another example that's not presented in the documentation, but again, to show the point here. So I want to write an alias here. I'm going to call it s, modified equals Typedef, and for the s structure. And then I will create with s modified the type here. Let's do s modified, s example, and I should be able to call s example.callMe. Okay. Again, this is just to show you that you get the same functionality from your Typedef, but if we want to check if these values are the same using the is operator, which we learned about last time, or is expression, excuse me, let's go ahead and check here. So let's say if is, and what I'm going to be comparing here, s modified, and I want to check if that is equivalent, okay, to s here, okay, and I'll say, if I write line, s modified equals s. Otherwise, let's go ahead and do an else statement and a write line here, s modified not equal to s, which is expected. Okay, let's go ahead and try that out as an example here. And we can see that, again, they're not the same types, because this is wrapping the type in this typedef, okay? That's basically what it's creating here, so that it can be seen as a different type here, okay? It's just basically a template wrapping the functionality here. It might actually be interesting to see in the Phobos library, if you want to do a little bit of an experiment here to see how the implementation details work. But hopefully, again, that kind of makes clear. Again, that's showing with this example here as well. Same idea. If I have an integer that I'm creating here, it's not the same thing as just a regular int, because again, it's your typedef that you created for an int. Okay, now we can also add some additional parameters here. Like for instance, we can change the initial value here. So for instance, for my int type here, I could pass as the second parameter here a different initial value, because again, if you're wrapping or creating some new type, you might want to do this. So let me show you an example of this. And this is just something I want to bring to your attention to, because it's always forgotten. It's probably a longer discussion on my opinion about if this is the right thing to do. But for instance, if I just write out the value for a float here, the default value is not a number. Okay, some people don't like that, or it's not something that you're used to. I personally think that's actually a good thing. But again, that's probably a longer discussion, and we can have various opinions about different domains where that's the right or the wrong thing to do. But let's just go ahead and create a new type here called float. And I'm going to use typedef again for the float, and I'm going to set the initial value to 0.0f. I'll go ahead and create f2 here and write out f2's value. And let's just go ahead and give ourselves a little bit of documentation here, just so that we can see a little bit more clearly that in fact we should get a initial value of 0, which maybe you're used to. And again, it's just very easy to use this typedef and make sure that you have that functionality. And again, you probably want float, for instance, as a typedef that's initialized in this way. Then you don't have to forget to initialize this if you don't like the not a number and so on. But again, this is another tool that you have here. Okay, let's go ahead and show the final example here, which is the string. It's called the cookie here, which is an optional used to create multiple unique types, which are based on the same original type T. And that's going to be that example with euros and dollars. So let's go ahead and check this out here. Now we've talked about traits briefly. If you want to briefly look at this example here, where you can check and see if something compiles, for instance. Again, this example is basically just showing you that int is different than my int. Okay, so that's what we want to show here. Or rather, they're showing the opposite, that this shouldn't compile. I shouldn't be able to take my int, take a regular integer, and take int, take the special new type that we created here. So either way, however you want to think about that. But anyways, for the last example, I'll go ahead and show you this alias here with the euros and dollars here. So let's go ahead and just write one more here, because this is a nice one here. Let's do money in euros. And this is going to be a float for the underlying type. Again, these are the template parameters here coming right after the exclamation mark. We could use the float init value here. Again, don't forget about these properties that we have with every type here. Or you could, again, just set it to 0 if that's what you're used to. Again, I think it's probably the right thing to do to take the underlying type here. And let's go ahead and use that for euros and dollars here. And let's, again, check here if indeed euros are equal to dollars. We'll go ahead and use a static assert to check this out at compile time. And we should be able to say that these are not equivalent. Well, I could write this either way. So I'm going to say is, let's see, money euros should not be equivalent to money in dollars. Okay, right, there is a currency exchange rate here. And with our asserts, we should probably write a message here. Expected money, euros, to be different than dollars. Okay, so something like that. Let's go ahead and compile it. Oops, let's see here. What did I, probably missing a parentheses or so. Let's see. And I made a nice little mistake here with is, because we should be checking for equality here. I don't know if I mentioned that in the last video where I did is, but that's the proper way to do things. So again, this is passing here, this assertion message, and we are good to go. Okay, so there you have it. We have the use case here for Typedef, which is quite nice here. There's a little bit more here on the type constructors as well. There is TypedefType here, which allows you to get the underlying type which a Typedef wraps. Let's go ahead and just do one example here, just so you can see what the underlying type. Again, this could be useful, but basically the idea is, let's just code this up for, let's do it for euros here. Just to show you one more example here, let's use a static assert, and we're going to use is again, and see the type def, so the type definition for money euros, and we want to check that that's equal to a float here. Okay, so let's make sure that that assertion passes here. So one just bonus tool here in the last minute or so of this video to show you here. And then you can do other stuff like the conversions and so on, so feel free to check that out. All right, folks, so hopefully you enjoyed this lesson here. Let's go ahead and get the code on one page for you here, or close to one page here on Typedef. Again, that's part of our TypeCons or type constructors here. Nice little tool in the deprogramming language, a nice way to wrap up types. Again, if you need some sort of primitive way or a way to get started with having units, for instance, for things like currencies, this is probably the right tool. You could probably also build on top of this if you wanted to, for instance, make a units library, and we're thinking about things like millimeters to centimeters and so on. And then you'd be able to kind of check the types and do some conversions and so on. That would require a little bit more work, but for something like this, euros to dollars, probably the right tool and a nice built-in tool that you have. All right, folks, with that said, thanks for bearing with me, and as always, thanks for your time. If you want to go ahead and check out more lessons on courses.msha.io, this is free to sign up for and track your progress. So I'm usually showing you that. You know that by now. But anyways, hopefully you enjoyed that lesson, and let me know if you're doing anything cool with Typedef, or you found it a useful tool, or maybe you've implemented something on your own that does something similar in the comments below. Anyways, folks, I look forward to seeing you in the next one.